Hello all, I am Manohari working as an assistant professor in SNS College of Technology from EC department. Today in industrial automation we are going to discuss the topic in local control unit in distributed control system. Before moving into that, what is distributed control system? Distributed control system is a computerized control system where control is distributed across the multiple controllers instead of relying on a single central computer. Think of it like a team sport. Instead of one player doing everything, every controller has its own role, working together to achieve a smooth operation. Let us empathize why we go for a distributed control system. This approach greatly improves reliability because there is no single point of failure, and it also makes the system more responsive to change in complex industrial process such as in chemical plant, power station or oil refineries. So, the single point of failure and enables a more responsive control of complex industrial process. We need a better solution. We need a better system. So, we go for a distributed control system. Here, the local control unit comes into the picture. Let us focus on the local control unit. Local control unit nothing but a LCU. LCU is a dedicated control. Within a DCS architecture, it is usually installed close to process equipment, right next to machines, sensors or actuators that need to control. Why it is important? Because being near the equipment means LCU can respond quickly to changes. For example, if a temperature sensor detects a rise in temperature, the LCU can instantly adjust the cooling valve and without waiting for instruction from the central computer. So LCU is essentially the frontline controller of the DCS, managing a real-time process variables such as temperature, pressure, flow control and speed control. What is the function? Next move on to function of LCU. LCU have a local control unit is more than just a mini computer. Let us break down the main function. First one is a process control. It executes the algorithms like a logic and sequencing. For instance, for example, we take a power plant. It might continuously adjust the steam flow to maintain a stable turbine. Next, move on to data acquisition. LCU collect a signal from a field device, sensor, transmitters, activators, and tuning a raw data into useful process information. Next, move on to communication. LCU don't work in isolation. They exchange information between the field device, central control room, and ensuring the operator always have to complete view of plant operation. Next, move on to fault tolerance and reliability. It's a key benefit. It's a key benefit in a local control system. Even if a communication with a central system fails, the local control unit can keep running locally. It's preventing a shutdown of the whole factory. Next, move on to human-machine interface. Some LCU have a small display or a control panel, letting operator check the status and make quickly adjustment directly at the site. So, in short, LCU with a local brain, keeping a process stable. This one is a visual representation of the local control unit. Here you can see how the local control unit fit with the DCS structure. The field device, sensors and activators directly connected with the LCU. LCU then communicate upward with the central supervisory system. It's a downward, it talks to equipment and ensures a stable control. And upward it sets a data and status with the operator and higher level or superior level systems. This layer approach make the entire plan be a flexible one. Next, moving on to advantage part. Why the industries adapt LCU? Let us summarize what are the advantages of having the LCU. It reduces dependency on central control. If the central system goes down, the LCU can still manages the process locally. Then faster response time. The LCUs are near the equipment, so it's a minimal delay for responding. Then improved tolerance. Even during a network disruption, the local process remains stable. Then scalability. If a plant expands, adding a more LCU, making the system flexible and easy. We can easily add a more local control unit. Imagine an oil refinery with hundreds of units without LCU. A very small change could travel to all the way to the factory and control back. But with LCU, each unit react instantly. Coming to the final conclusion, to wrap up the local control unit is the backbone of the DCS architecture. It provides a real-time control at the process level, ensures reliability and even during failures, and allow industries to scale that system efficiently. In short, local control unit act as a local guardian of industrial automation. Thank you. Thank you for watching. We will meet in another session.